So the first part of this chapter I'd like to review a little bit. I know it's only been a few days, but we've covered so much material, so I always feel like it's useful going over it. So we're going to be talking about molecules and compounds, and in that discussion we're going to be talking about how we name them and write their formulas from their names. Okay, so that's the big objective for this chapter. So to start with, we have atoms and we have elements and we have compounds. So atoms are the smallest building block of matter, basically. I mean, there's subatomic particles, but of the things that are bigger than the subatomic particles, atoms are the building blocks that make everything up. So, we have atoms like iron or mercury or lead, those kinds of things. Those are atomic elements. But we can also have within the term element. So atoms are the smallest thing, and every element on the periodic table is made up of atoms. Now those elements then can either be atomic, so like the ones I chose for iron, or let's say chromium, or potassium, or sulfur. Those would be, potassium. Those would be examples of atomic elements. But then there are diatomic elements. So these diatomic or sometimes polyatomic elements include the 7 that are shown over here. So these are all molecular elements, and by that what I mean is they come in the form of 2s, okay, for in the example H2. So when you go out into nature and you get hydrogen gas, or you generate hydrogen gas in a chemical reaction, it's always, the elemental form of hydrogen is always H2. For oxygen, it would be O2. So this 7 that's here, say I like to draw this way because it looks like a 7 and there's 7, right? And it's the top right-hand corner of the periodic table. This looks like a 7. These are the diatomics. So the diatomic elements are all nonmetals. In fact, all the polyatomic elements are also nonmetals. The other 2 that are of interest are P4 and S8. S8. So these are elements, because remember, to be a compound, we talk about compound, and I'll review it here. There's 2 or more elements, so these are all one kind of element as a pure substance, right? These 8 atoms of sulfur, for example, float around together as almost like if you've seen a stop sign, you see the shape of a stop sign, and it has 8 sides. It's like a stop sign that's been wrinkled up. It's been like crushed a little bit. Okay, so that's kind of what it looks like in its shape. Now, compounds have 2 or more different elements. So a compound would be, for example, H2O. That's the one we use most commonly as an example. But it could be glucose, which is C6H12O6. And it could be things that are even more complicated than that. But these are example of compounds because they have 2 or more elements. This is one type of element, as are these. Now the diatomics, those you need to memorize. These other polyatomic ones aren't so important. And the atomic elements, right, are everything that are not diatomic or polyatomic. So when you look at the periodic table, you recognize, let me get my mouse going here, that these represent most of the nonmetals, right? So, but these ones here on the top right-hand corner, those are the diatomics. Phosphorus and sulfur are the polyatomics, and then everything else is atomic. Okay, so let's do this real quick. You might want to pull out a periodic table and identify these as being either atomic or molecular elements, and then write their formulas. Write the formula for the element as we would find it in nature, okay? So let's look up chlorine, right? Chlorine from the periodic table. Now chlorine is in the top right corner underneath fluorine. Now I left the noble gases off on the side over here. They're not part of this discussion, but those are also atomic elements, okay? but chlorine would be one of the diatomics. So when you write its formula in chemical reactions, or if you're asked to provide the formula for chlorine, right, it's going to be Cl2. Remember, the subscript indicates how many of those atoms are present. Now, if we look at argon, we're going to have to pull up a different periodic table. And so I pulled this one up again, and we have to find argon. And argon is over here. Well, I guess I can write on it with this. Is over here on the periodic table. I'm not sure why I didn't write, but let's try it again. There's argon. There we go. So argon is not one of the diatomics. So if you were to write its formula, it would simply be written as AR, like that. Now we have to look up cobalt, right? Now we're going to pause real quick and see if you can find cobalt on the periodic table. And so if you see it, it's in the middle of the periodic table here. So again, the diatomics are over here, and they include hydrogen as well, right? So since cobalt is not one of those, if you write its formula, you would simply write CO, and then hydrogen, its position, again, it's over here in the top left-hand side, but it's one of the 7. So the part of the 7 is the H, or the is NOF, and then the Cl, the Br, and the I, and then hydrogen is one of those. So since hydrogen is one of the diatomics, we would write it as H2 for its formula.